Hello everybody, this is Mr. Munson, and we're in chapter 4 still, and this is congruent triangles, the chapter is. Today is concept 4, isosceles triangles. So, we're going to be talking about pieces of isosceles triangle being congruent. Hopefully you know the definition of an isosceles triangle is that two sides are congruent to each other. And we're going to learn some things about isosceles triangles. Now, what we're learning today is going to help us later on in the chapter when we really start talking about congruent triangles. We're going to be looking at a pair of triangles and asking ourselves, are these two triangles congruent? And we're going to need to know the facts of the isosceles triangle at times to do that. That is one nice slice of cheesecake there. Obviously the cheesecake is not an isosceles triangle, and the reason is because typically cheesecake is round. And so this would have an arc on it. So we're really looking at a sector. We learned about those back in the circles. And so an interesting question would be, what is the area of the triangle? Let's move on. So I had our vocabulary words started from last time. We're going to zoom in and look at base angles and a couple other ones here. All right, so before we get to base angle and vertex angle, I want you to add legs to the bottom of your page there if there's room. We need to make sure we know what a leg is in an isosceles triangle. So by definition, the congruent sides of an isosceles triangle are called legs. And so if you look at the blue triangle there, two sides are marked congruent, and those are called the legs. Sorry, those are the legs there. Okay, so we would write that, AB, segment AB and segment BC are the legs of an isosceles triangle. All right, let's do the two that we missed already. Okay, the angles opposite the congruent sides of an isosceles triangle are called the base angles. So here I have an isosceles triangle there in the blue. And so if I go and look at this angle that's over here where I just marked green, if I go to the angle that's opposite that side, that's one of the base angles. And then I do the same thing over here and I find the other base angles. So the stuff marked in green, the two angles marked in green are the base angles. So a vertex angle is a unique angle in an isosceles triangle. The two sides that are congruent of an isosceles triangle form the vertex angle. So if you look at my drawing here, I'll color in the vertex angle. So it's the one angle that's at the top here. Okay, now it's not always at the top. I can turn an isosceles triangle upside down and it'd be on the bottom or on the side or whatever. It plainly stated it is the third angle that's left over. Once you find the base angles, it's the last angle. All right, so side that's an opposite side is side opposite an angle. So take a look at my drawing there. I have a red kind of highlighted that angle C. And so what we find is that side that's opposite that is across from it. Okay, it doesn't make up the angle in any way, it's just across from it. And so AB is the opposite angle to angle C. And we write it simply as the segment AB is opposite angle C. Okay, just do a real quick check to make sure that you understand this concept. Go ahead and write in what you think the answer would be on that line there. Something, a segment is opposite angle B. You should have wrote AC. Okay, sort of conversely, we can talk about opposite angles. It's basically an angle opposite a side. So as you can see in the triangle here in green, I have a red side AB, and so the angle opposite it is that angle that I just pointed to, angle C. And so I wrote C is the opposite side AB or segment AB. Let's go ahead and check your mini understanding of this. I find this can be quite confusing to a lot of students. So what I always tell them to do is highlight the thing that they're given and then use an arrow to point to the angle opposite or the side opposite, just as I've done in my drawing. So go ahead and write in the answer there for the underlined part. Hopefully you wrote angle A. If you understand that, we're ready to move on. Okay, I want to do a real quick construction of an isosceles triangle with my compass and straight edge. It's very simple to do, just watch. I'm just going to open it up some arbitrary amount, strike that arc. I'm going to take my compass and move it to the other side. keeping the same size measurement. So now what I know is from point B, where my compass was at, to where these two intersect is exactly the same distance because I kept my compass the same width as from A to that point. And there I have an isosceles triangle. So I know that these two segments here are congruent to each other. I don't know anything about the bottom side, which we call the base. Let's do some investigating real quick. Okay, just to verify, we're going to use a ruler. It looks looks like it's just a little bit over 7.5. You can see in this case from the other side, it's still just a little over 7.5. So definitely have a isosceles triangle. So let's kind of move this up into a little bit better position for me. And let's um, let's do some measuring of some angles. This angle over here, once I position it, looks like it's going to be about 45 degrees. Cool. Okay, and if we look at the one at the top here, this angle here is about 90 degrees. Now, definitely we know by the triangle sum theorem that if that's 45 and that's 90, and the two have to add up to 180, we should be able to calculate that one without even using a protractor. We'll bring it in there just to confirm. Well, something happened to my protractor and I can't get it to work. So definitely we can just use our triangle sum theorem to realize that all three of those angles need to add up to 180. That does leave us with 45 degrees down here. It's not by accident that those two lower angles are exactly equal to each other. What we find out in an isosceles triangle is that the angle opposite the congruent sides are actually congruent themselves. And that's in all isosceles triangles. So in an isosceles triangle, you got two sides are congruent, guaranteed two angles congruent. Let's move on. All right, let's make sure we understand our words here. So we've got an isosceles triangle here. Let's go ahead and mark these sides congruent so we know which ones we're talking about. And so the sides that are congruent called legs. The bottom side, the side that's not necessarily congruent to those other two, is called the base side. And the angles that sit on the base are called the base angles. That's pretty much it. Here's what I need you to know though. If this thing's sitting on its side, those are still base angles. Even if this thing's sitting on its side, that green leg is still a base side. Okay? It has nothing to do with its position on the page. It has everything to do with it. It's not a leg. And the legs are always the congruent sides. So here we have what we call a theorem, an isosceles triangle theorem. It says basically if two sides of a triangle are congruent, then the angles opposite those sides are congruent as well. Okay, so if this over here, if this is the situation we're looking at, a triangle with two congruent sides, then we conclude, and remember this symbol, I've done this before, an equal sign with an arrow, then we know that the angles opposite those sides are congruent. So we get to mark those for free. Okay, now see how I drew those arrows there? As we're working through these problems, I'm going to encourage you to make sure you're drawing those arrows. When you draw those arrows, it'll automatically help you remember to mark those angles congruent. Well, what we find out is that the converse is true, and that is, you know, if I have a triangle and these two angles are congruent down at the bottom, or it doesn't matter if the thing's turned, I just have two angles are congruent. What ends up happening is the sides opposite them end up being congruent as well, just as the picture shows. Very simple stuff. So let me ask you a quick question. I use the word converse. I want to know if you think you know what it means. So what do you think the converse means? And go back and listen to me talk about it in that previous section. Just rewind me and listen to me talk about the converse. And I want you to understand what that word means on your own. So maybe it means even going to the internet and taking a look at that. All right, let's take a look at some examples that you're asked to find x. So as I told you before, I can see that those two sides are congruent. I'm going to draw arrows to the opposite angles, and then that will help me remember that those two sides, those two angles are congruent. Easy enough. I know x is equal to 75. The reason? The isosceles triangle theorem. right? The Isosceles Triangle Theorem said that if those two sides are congruent, the angles opposite them are congruent. This is, we're headed in a direction where we're going to need to be coming up with our reason why we're going to be writing proofs. And it's going to be very important that you follow along and understand what I'm talking about when I do that. Okay, here we are to find x. Hey, so I'm looking at this and I see the two congruent angles. I'm going to draw arrows that point to the opposite angles or opposite sides, and from that I can conclude that x is equal to 6. Why? Because of the triangle, isosceles triangle theorem. You ready for it? Converse. Okay, this one says if the bases are congruent, then sides congruent. Okay, those were a little bit easier. And so I want you to see if you can figure out how to do this one. This is a little bit more challenging. Put some thought into it. Okay, use your arrows to point to the angles that are congruent. Set that up, and then see if you can figure out what x is. Put me on pause. Come back and check with me. That wasn't too hard. I used the triangle sum theorem to set up the equation there. Let's summarize why this is the answer. Again, try to do this on your own so you're thinking it through. Now, there's different ways of writing this and different ways of coming about. Yours might be just as much accurate as mine is. I'm going to write mine now. All right. By using the Isosceles Triangle Theorem, the two base angles are 75. I found x, the third angle, by subtracting the base angles from 180. Okay, that's all I did. I just put it in writing form. Let's move on. Okay, here's another problem. This is a little bit more advanced. See if you can kind of work through this one and do it on your own. Use your arrows to point to things. You're going to have to use some previous knowledge to get a little bit further. Let me challenge you on this one. Put me on pause. Come back and check it. Okay, so I know that by those two sides being congruent, the opposite angles are going to be congruent. So I use my arrows to help me point to what angles. This is obviously 47 degrees. I'm trying to find angle 2 though. Now I'm going to use vertical angles to bring the 47 degrees in there. Now what I know is that these opposite angles and opposite sides are congruent, right? So that means this is 47 degrees over there. Quite simply put, I know that 180 equals that 147 plus that 147 plus the measure of angle 2. Now it's just a matter of solving and coming up with the measure of angle 2 equals 86 degrees. Now you probably were wondering if I was going to have that train wreck happen at 147 degrees I was putting in there, but by the magic of editing, I fixed that. All right, let me challenge you with this problem. Right? So I'm asking, is segment AB congruent to AC? So you're going to have to come up with a reason for that. Write it out in words. Put me on pause and come back and check to see what I got. Okay, see if you follow my logic here. I say yes, they are congruent. Since angle B and C are congruent, the sides opposite them are congruent. So I'm going to reach all the way past that distracting line that's just placed there for no reason. And I'm going to reach all the way across here and point to that one. And so those two sides that they're asking about, A and B and A and C, are congruent. I use the Isosceles Triangle Theorem Converse as my authority to say that those things are congruent. Okay, the converse is the one where the angles are congruent, then the sides are congruent. The Isosceles Triangle Theorem is the sides are congruent, therefore the angles are congruent. It's just a quick extension to the Isosceles Triangle Theorem. It basically says this: a triangle is an equilateral if and only if it's equiangular. But think about this. I have this triangle over to the left, and that angle right there is definitely congruent to that angle right there. That's the Isosceles Triangle Theorem. But if I was to turn this and say that angle right there is congruent to that angle there, well, the one over here is already marked as a single green line. So since those two angles are congruent, I can now conclude that that is congruent. And that's how I get that conclusion, okay, that the angles would all be congruent. All right, and that's it. Let's take a look at our try-it problems. Pretty simple stuff. Go ahead and do those problems. Bring them in next class.